take a look at some of these polynomials. So it says list all the rational roots, all possible rational roots, right? That's going to be key. Test your possible rational roots until you find one that works, and then write the polynomial in factored form. These are kind of the three general steps that you need to take into account when you are solving these polynomials, or like when you're trying to factor them. But there are some like intermediate steps that we need to take into account. So list all possible rational roots. This is the rational root theorem. Rational root theorem, where it's the factors of the constant divided by the factors of the leading coefficient, in this case 1. So -4 is plus or minus 1, plus or minus 2, and plus or minus 4 all over plus or minus 1. Right? There's no other ways we can do that. Now, the way that I like to set this up is I just make my list. I don't worry about trimming it down or reducing any fractions or doing anything like that. Just simply list them all and we can clean it up after the fact. So we have plus or minus 1 over plus or minus 1. Plus or minus 2 over plus or minus 1. And then plus or minus 4 over plus or minus 1. Now, there is no other second denominator here, so we don't have to worry about going through this process again. And so what we end up getting is plus or minus 1, plus or minus 2, and plus or minus 4. So we have 6 possible rational roots that we can try, that we can check. Now, if you were to use a calculator and just plug this into a calculator real quick, you would just substitute these in until you got the ones that worked. Or you could use a graph or look at Desmos or something like that. So if we were to look at Desmos, we would get, let's see, x, where's the little caret? Oh, there it is, x to the 4th plus 3x squared minus 4. Okay, so it looks like we will have a root here at -1 and a root here at +1. So we can assume that that is accurate. So we get x equals -1 and +1. And so if we were to turn these into factors, we would just add and subtract 1 to the other side. So we get x plus 1 equals 0. So there's one factor, and x minus 1 equals 0. Here is a second factor. Notice that this is a degree 4, so we should expect to see 4 roots, whether that be a combination of real and complex. Only complex since it's positive and even, or since it's even, or whether that all be real. So from what it looked like on the graph, it looks like we only have 2 roots that cross. They don't bounce at all, and so that would suggest that there might be some complex roots that are going to show up. And so until we start dividing, we won't be able to know that. Okay, so we're just going to ignore this one, and so I can use the space to kind of continue this math. Okay, so we tested possible rational roots until we find ones that work. Here they are. Here are the ones that work. And then we need to write it in factored form. The only way we're going to write this in factored form is if we start dividing and getting the factors. So I'm going to use the long division. You can use the box method or whatever method works for you. I'll start with x plus 1 here. And we'll divide by, let's see, this plus 0x cubed plus 3x squared minus 4. Let's see, this will be x cubed, that's x to the 4th, plus x cubed minus, those out to 0, negative x cubed, plus 3x squared, because this drops down. We get negative x squared here, so we get negative x cubed minus x squared minus, so this turns into a positive, this is a positive 4x squared minus 4, and this would then, oh, I forgot the 0x plus 0x. That would be 4x here. So 4x squared plus 4x. Subtract those, add to nothing, negative 4x minus 4. And lastly, that would then be minus 4 here. We get negative 4x minus 4. We subtract that. That adds up to 0. So no remainder. Good. That's what we wanted. So now we have x to the fourth is equal to, or excuse me, x to the fourth plus 3x squared minus 4. And that is going to factor down into x plus 1 times x cubed minus x squared plus 4x minus 4. Okay. Now, like I said in class, now that we've kind of split off a factor, we keep dividing this by factors that we have that we know that work. So we have an x minus 1 factor, and so we're going to repeat this process again, but we're going to divide this by x minus 1. So x minus 1 divides into x cubed minus x squared plus 4x minus 4. This will be x squared, x cubed minus x squared. Subtract this, that's a 0, that turns into a positive, that goes to 0. So it looks like we have 0 here, plus 4x. Plus 4. 4x, right? Nope. Plus 0x plus 0x. Because this is 0x squared. This would be 0x squared minus 0x, which is then 4x here. Bring this down, minus 4. And this would be a positive 4 here. So we get 4x minus 4. Subtract those, adds up to 0. Okay, so now we have another step in our factoring process. We have x plus 1, x minus 1, x squared plus 4. This is an irreducible quadratic factor. Irreducible in the fact that we can't make this any smaller without changing number systems from the real number system to the complex number system. So what we would do here, this would be, in my opinion, this is a completely factor form. This works. If you were to take this a step further, because we had to find the zeros and find the roots for this, we would have to then deal with this. And so to deal with this, we have x plus 1, x minus 1, and x squared plus 4. And we want to set those all equal to 0. And we're going to find all of the roots now that we're going to need. So x plus 1 is equal to 0, x minus 1 is equal to 0, and x squared plus 4 is equal to 0. So we have x equals 1, negative 1, x equals positive 1, and x equals the square root of negative 4, or x is equal to plus or minus 2i. And we know that we're finished because we had a degree 4 polynomial to start with, and we have 1 root, 2 roots, 3, 4 roots. So we have 4 total roots, 2 are real, 2 are complex, and so we know that we are finished. And so that is more or less the entire process that you're going to have to go through. Sorry I went vertical, or sorry that I went horizontal and not vertical. But the better you get with this process, the faster and more compact you'll get. I just wanted to make sure I laid out all of the steps that were needed, which is now showing me that you need more space on these problems. So in my opinion, what I would do is I would go back and I would try your hand at 3B, 3C, and 3D and kind of see what you get. Come to class, ask me for help, because since they're on here, they are fair game to show up on a concept check or an exam. But that is the kind of the full process that you would have to go through in order to find a completely factored form and all roots, right? Both real and complex. Hopefully that was informative and helpful, but there it is.